a couple more examples. So we're going to find the angle between two vectors. So when we graph two vectors, ooh, highlighter. Okay, when I graph two vectors, they might not be on the x or the y-axis. So I need to be able to figure out the angle between two vectors that are not necessarily easy to find the angle between. But if we remember from the first video, we have a dot product rule that is the magnitude of u, so the first vector, times the magnitude of the second vector times the cosine of the angle between. We can actually isolate the cosine theta for our amusement. That's so many vertical lines right there. So we get the cosine of theta is equal to the dot product u times v over the magnitude of u times the magnitude of v. And that's what we get over here. Then you have to take the cosine inverse. So let's do one, okay? So the angle between 3, 0 and 1, 6, that's kind of like the first example that we used in the last video, I think, or pretty close at least. So we're going to need, I'm going to use the cosine of theta is equal to the dot product of u times v over the magnitude of u times the magnitude of v. Okay, I definitely need the magnitudes. So the magnitude of u is equal to the square root of 3 squared plus 0 squared, Pythagorean theorem, which is just 3. Okay? The magnitude of v is equal to the square root of 1 squared plus 6 squared, which is the square root of 36 plus 1, 37. Okay, so plug it in. The cosine of theta is equal to, let's see, the dot product. So 3, 0 dot 1, 6 over 3 times the magnitude of v, which is 37. Okay, we need to calculate the dot product to give us a scalar. So 3 times 1 plus 0 times 6 all over 3 root 37. This gives me the cosine of theta is equal to 3 over 3 root 37, which is 1 over square root 37. And I'm going to go ahead and inverse this. The cosine inverse of 1 over square root 37 is equal to theta. So theta is equal to 1.515 radians, or 85.859 degrees. Sometimes it's nice to see this in degrees. Okay, so some algebra for you. All right, number 6. Find u dot v, where theta is the angle between u and v, and we're given that the magnitude is 100, the magnitude of v is 250, and theta is equal to pi over 6. So I could start with this equation, but why don't I start with that equation? Because they are the same, they're just rearranged differently. Okay, so let's do u dot v is equal to the magnitude of u times the magnitude of v times the cosine of the angle between. U dot v is equal to the magnitude of u, 100, times 250 times the cosine of pi over 6. I know from trig, all y'all's favorite subject, that this would be 100 times 250 times root 3 over 2, which simplifies down to, let's see, Well, the 2 and the 100 cancel to give me 50. So 12,500 times the square root of 3. That would be our dot product. All right, lastly, from when we calculate a dot product, we can figure out if the vectors are perpendicular. So something like this and like this. They don't actually have to connect, okay, but they can be perpendicular in direction. Or if the vectors are parallel, obviously these are not going to connect. Those don't look very parallel. Okay, parallel. By calculating out the dot product, and if the dot product equals 0, then the vectors are orthogonal or perpendicular. Think for a second, u dot v is equal to the magnitude of u times the magnitude of v times the cosine of theta. So since we're trying to get this 0 thing, if we use the cosine of 90, which is, perpendicular, cosine of 90, let's put up here, cosine of 90 degrees is equal to, that's right, 0. So when I multiply by the magnitudes, this is just going to give me 0 anyway. The rule for parallel vectors is a little bit different. If the components of u, so u1 comma u2, are equal to the components of v1, v2, but scaled by some number, then we know that the vectors have the same slope, so they are parallel. So let's look at example 7a. I'm going to go ahead and go u times v is equal to the magnitude of u times the magnitude of v times the cosine of theta. And then I'm like, I don't want to use that one because I don't really know what the cosine of theta is between them. So I'd rather use this equation, or u1 v1 plus u2 v2 equation. Okay. So I get negative 12 times 5/4 plus 30 times 1/2, which gives me, let's see, it cancels to give me 3. So negative 15, plus 15 gives me the dot product 0. Therefore, the vectors u and v are orthogonal. No. Or perpendicular. Okay, so I'm going to try B. So let's see, parallel or orthogonal. Well, when I look at u, so this form right here is, these vectors are written as a linear combination. Okay, let's write these in component form. So u is equal to 2 comma 4, and we're going to dot that with negative 4 comma negative 8. Okay, when I take the dot product of these, I get 2 times negative 4 plus 4 times negative 8. I can see that this is not 0, so these are not perpendicular. They're not orthogonal. So not 0, therefore not perpendicular or orthogonal. So let's try something else. Let's look. Okay, so the components 2 comma 4 is equal to negative 4 comma negative 8. So is there a value, some scalar m, that would give me negative 4, negative 8? Yes. I can multiply it by negative 2. Negative 4, oops, did that wrong. Negative 2 times 2 times 4, 2 comma 4 is equal to negative 4 comma negative 8. So therefore, the vectors u and v are parallel. When you break it down, vector u has a slope of 4 over 2, and v has a slope of negative 8 over negative 4, which both of these give me actually a slope of 2. So, parallel. All right. Hope that was fun.